What's up, guys? Welcome back to LeetCode Path to Pro. Today is Monday, February 19th, start of the week. Let's get after it. Hope everybody's doing well. Yeah, I'm going to go through this BiWeekly Contest. So we already did the easy for it. I'll pull it up again real quick. It's pretty straightforward. So we're given an array. Well, I guess I'll go through the description first, and then here can we... What's this going to do? And the only reason it looks so fast is because, but anyways. So we're given an array of integers called nums. You can perform the following operation while nums contains at least two elements. And we're guaranteed that nums contains at least two elements to start, so we don't have to worry about that edge case. We're going to choose the first two elements of nums and delete them. So the score of the operation is the sum of the deleted elements. Your task is to find the maximum number of operations that can be performed such that all operations have the same score. You want to return the maximum number of operations possible that satisfy this condition that they mentioned. If we look at this, we look at the first two numbers. 3 plus 2 is 5. We remove those two, move to the next two. 6 and 1, that's 7. We can only perform one operation, we get 1. Here, we remove 3 and 2, sum of 5. Then we go to 1 and 4, sum of 5 again. We remove both those. That's two operations. Our score is 2. So my solution. Okay, here we go. So I just have a result, which is storing, how many operations we've performed. Then I have a left and a right pointer. That is 0 index and the first index. I just create a current sum, which is going to be nums of L plus nums of R, so the first two elements of the array. Then I check while R is less than the length of nums. If nums of L plus nums of R equals current sum, result plus equals 1. So we know this is a little bit of duplicate code, right? We know that this is going to execute at least once because we're guaranteed that our array is at least 2 elements long, and then we've already found the current sum to be nums of L plus nums of R. So we know this is going to increment once, right? And so it increments once, then we move our left and right pointers 2 over. And this while loop might stop executing if the R is outside of bounds. And we're just checking the R because it's farther along. It's at a higher index in the array versus the left. And then we have this else break because we don't want to just keep looping through if we hit two values that don't add up to our current sum, right? Because then we could find something further along in the array that also equals current sum, but that would be illegal because we wouldn't have deleted the two previous elements. And then at the end of this, we should return our result. So not too bad of a problem. Ooh, can we do the virtual contest? No, that's not it. I hope we get a score. All right, so apply operations to make string empty. So let's go ahead and try this. So you're given the string as consider performing the following operations. Oh, interesting. Oh, this is a really interesting problem. Huh. Okay. So let's start walking through an example here. So let's say we had like, I don't have my mouse, so the drawing's gonna be really bad. Let's say we had like A, like 4A's, a BB, maybe a C, a D, a C, and a C, right? Something like that. So we go through, we remove A, B, C, D. So we're left with A, B, C. Move A again, B, C. So we got AA and C. Move A and C, and then we're left with A. What happened if we had like just A's, right? And like a C. All right, we remove this and this, and we'd be left with AAA. Would we return that? I think we'd return just a single A, right? Yeah, okay. So this isn't too bad. So create a counter, counts equals counter. Is it a counter? Counter of S. Then right, if we print our counts, we just return A. Right, so this counter, now we just need to return everything with the max occurrence, right? So max occurrence, max of what, counts.get or something, right? To get max value from, oh, okay. My screen's been going black recently. I think it's a hardware issue. So max C. We just do max counts. It's gonna return probably the value or the key, right? Yeah. And that's not even the max. That's very strange. Does it just pick an arbitrary? Oh, yeah, B. There's more B's and A's. What? Oh, maybe because C is. Yeah. C is the largest Unicode value. Counts that value like that. Sure, value. All right, bet. So that's what we want. Yep. All right, and then we have our result string. We have to keep care. We have to be careful. We got to keep it in order. I guess we can loop through the string, right? Yeah, we could for character in S, right? If counts of S, so equals max occurrence, then result plus equals character. And character not in result. Yeah. Because we only want one, right? So I don't think we're adding anything. Oh, sorry, that's a C. Okay. B. Oh, it is trickier than that. So we remove the first occurrence. So we gotta go backwards. Right. I think we might have to go backwards through it, right? If counts of S of I and S of I. Let's see if that works. Oops, sorry. S of I. No. What the heck? So, yeah, that's true. No, that's not. Print. Let's print. sub I, print result. See what we're getting. A. Hard to tell. Excuse me. A is our result. B, what we want. Let's see, like this, result equals S of I. Just do it like this. Let's go. Nice. Heck yeah. Cool. That's sick. Okay. So let's think about time and space. So space, O of n, right? We're creating a result. We have our counter, O of n. What is time complexity of counter? Can't imagine it's more than. Yeah, construct as O of n. So O of n, this is O of n. And then we're checking. I think this would be O of n times k. Or would it be O of n squared? Right, the issue I'm thinking about is this right here. Checking, yeah, I guess. Checking if. Yeah, it's O of n. So this is not O of n. Yeah. O of n squared. Let's see. O of n code. Oh. Your turn, yeah. Yeah, we can do better, so. Right, and then so this would guarantee that we never. Right, yeah. If we do this again, it should be faster. Not noticing. So I guess this is taking up a significant amount of time. So here's using. So did you make the list? Return. We'll make a string. Then we're going to join the result backwards. So this should be faster. Oh. Let's see. Let's see. So this is faster. Strings are immutable. Yeah. Cool. Cool problem. Solid. Happy. Mostly was able to solve it, so that's good. I don't know what this guy's talking about. Oh, one space. Brother, that is not one space. Okay. Counter. Max. Max. And then join. Yep, like that. So this is a string problem. Yeah, I mean, That's not open space. That doesn't mention. Let's see. Doesn't mention time or space. Maybe I'll go this one. Oh. David. Keep us in. I don't think so. I mean, maybe the solution. See, this is not. You got a counter there, bro. Oh man. Okay. It's oh man. It's really not over one. I think. Hey. Oh man. How do we solve that, dude? We might have cruised on this contest. If we could get this third one, it'd be a personal record. Oh, interesting. Ooh. You can perform any of them. Choose the. Ooh, interesting. Mm-hmm. So I think we have to do GP here. So you can do first, last, or first and last. And why I say we have to do DP is because this is, is essentially creating a tree of decisions for us, where depending on which, like let's say we're given some array that we could perform all three of these operations on, but by choosing one operation or the other, we would have more or less operations to do down the line. So yeah, I think we need to do DFS here. Right, and what are we gonna pass in? Like, we pass in our nums. See, well, 13. And operations. I think the nums is less than 2. Should be -1, right? Something like that. And then we also need to check if nums. Then this is first two, last two. Oh my god. We also need to. This needs to be our score. If score, then we can make our first two. DFS of passing our score. No, it shouldn't be our score. Oh, this is tricky. This does have to be nums, you know? We would also need to keep track of score. Am I overthinking this? This is a cool problem. Oh, we need to do array size, right? So start at 0, 1, and then get the whole thing. Yeah, we can do it like that, right? I don't want Slack notifications. Don't allow. Get out of here. Scene. Alright, well now we need to update scene. Oh, dude, I don't know. My jaw kind of hurts. I've been sleeping without my retainer, so my jaw hurts. Scene. What should be in our cache? Alright, obviously, like operations. Oh, I guess we have to do it here, right? Then scene. Of nums, this thing, equals operations. This one. So now we can pass in our scene. Score. Same. And then something like this, yeah. I'll have a few more. A couple more. So now, last two, if nums of -1, nums of -2, and then we want to start I don't remember, numpy, just regular. Why did I put too many commas? Start, stop, step. Yeah. So I put far too many commas. Oh no, I just have the two. So start. We want to start, stop. This is where we want to stop. Stop at -2. That's inclusive, so 3. And then this is last two. -3. Here, we need to check if that one, this one, start at the start. Or no, we skip the first. So this is 2. No, it's the end that's ICT. It's the end that's exclusive, so we need to do that too. So we skip the first. Oops. Fuck. First two. First and last. And we want to return the max. First two, last. And last two. And last. Here we return. Yeah, return max of. We tried 3 different scoring patterns, right? LTFS with nums, right? Regular nums. Scene, we score operation 0. Score is going to be what's it, nums? Nums of 0 plus nums of 1. Okay, so that's 1, DFS call. Or this guy. So none of this is going to change except the score we put in. So now we need the last two. 2, 0, 1. So we can't have our num says. Because this could change, yeah. Alright, well, let's see. Score. Yeah, cash tick. We are 0. Oh, and is he? Left, right. Flip. Okay. Okay. DB. Oh, interesting. This is a very good solution. I want to choose a regular cache. Oh, okay. Wow. Yeah. DFS, and then you pass in. Right. Start. So instead of nums. Okay. Yeah, I really like this solution. This is kind of what I was going for. Just reset. Whoa. Okay. So I don't want to use the just standard cache though. Put it at the end. Make it easier. Answer 0. If Store it as a tuple. Return start. Else. Anything else? We just add scene. Equals answer. He's resetting answer. Now this is just something we're passing in. That works. All right, let's just test this. ChatGPT. Get all this out of here. Use cache. I don't want to add cache. Here. I sure love the formatting of this. But it's kind of like Java formatting. So if it's in, so you got to keep track of the score as well. And then do this here. This is a good problem. It's a really good problem. This is DP. So there you guys go. I mean, I guess the only annoying thing about the format is this bit here, which we can fix it up. I used to be. So yeah, this is a really, really good problem. I think I'm definitely gonna come back to this problem. terms of understanding DP and recursion, pretty great. All right, so this is here. This is dynamic. So DFS. Oh, this is top down. So DFS. Right, that's what I said in the past, I think. Yeah, top down DP. Any other useful? If I guess it's 2-pointer too. Right. So I did not complete this one, unfortunately. And then it's a time and space. That's tricky. So the space is going to be basically whatever time includes degrees of recursion. I don't know. I'm pretty lost on that, honestly. So this is the same, basically, as mine. Oh, that's squared. Soluten. That's correct. It's O that squared. For both. Case one. Where's double O and squared? Nice! What is this? Snakes and ladders. Nice. Monsters. O and squared, O and squared. Alright, cool. 2 mediums. Anyone over easy real quick? I got one of the mediums, so pretty happy with that. Getting better at the DP stuff still, so that's good. But yeah, thanks for watching, guys. See you later.